recognize this sound. Perhaps this will tell you more. It's a reasonable operating pressure, isn't it? Imagine for a moment that you are the pump operator. Take a look along to where the pump is driving the water. Oh, it's out of sight. Well, let's sneak round the back and look. Something we couldn't do in an emergency. There may be 5 bars of pressure, but has the branchman got a good firefighting jet? As pump operator, what should you do? Apply the formulae? Look up the tables? There are a number of problems that can affect the flow of water at the branch end, where it's needed. Head loss due to gravity. Blocked hose from fallen debris or other obstruction. Frictional loss, where the hose lengths are long. The question is further complicated by the inclusion of foam and induction equipment. If you know the flow rate, you could set up the proper operating conditions for the inductor easily. Let's face it, in an emergency you need quick, reliable answers in order to tackle the fire efficiently, to say nothing of the safety of the branchman or the job of actually putting out the fire. Flow meters could provide a helpful guide as to the real situation at the branch end. Flow meters allow fast, easy setup time. For instance, if a branchman requires 150 litres per minute to operate his branch efficiently, the pump operator can provide it immediately. Even a simple meter would offer guarantees that were previously unavailable. Other important uses of flow meters include monitoring flow in water relays, monitoring total amounts of water used, vital knowledge when firefighting on board ship or where there is a limited water supply in rural areas. The continued use of the pressure gauge is still necessary in order to maintain safe operation of the pump. The two instruments should be used in conjunction with one another. The additional information supplied by the flow meter makes the pump operator's job more effective. The Fire Experimental Unit began investigating the use of flow meters in the different conditions encountered when used on fire service pumps. It was found that there is a wide variety of flow meters available, but the field was quickly narrowed down to 2 basic types which might be suitable for fire service use. The pitot type. This flow meter takes a reading of differential pressure across 2 sensors and converts the data into gallons or litres per minute. The paddle wheel flow meter. The paddle wheel is sighted part way into the flow. The speed of rotation is converted to indicate flow rate. This can be displayed on either an analog dial or digital display. Both flow meters can indicate not only the flow rate, but also the total amount of water consumed. Usually, manufacturers recommend that the meters should be fitted to a straight length of pipe in order to avoid the effects of turbulence. However, tests have shown that the paddle wheel flow meter is sufficiently accurate for fire service use, even when mounted near to the pump valves. It has now been decided to carry out brigade trials to assess flow meters under operational conditions. Conditions which at the best of times are far from ideal. The simple addition of a flow meter could avoid the problems of the past. For in the past, pump operators have had to develop a feel for the sound of the pump, alongside the ability to interpret variations in pump readings. And the branchman also had to do some mental arithmetic to get a good firefighting jet. This simple device can provide additional safeguards and make firefighting operations more efficient.